So now have a look at today's daily problem. 129. Some root-to-leaf numbers. Given the root of a binary tree containing digits from 0 to 9 only, each root-to-leaf path in the tree represents a number. For example, the root-to-leaf path 1 to 3 represents the number 123. Return the total sum of all root-to-leaf numbers. Test cases are generated so that the answer will fit in a 32-bit integer, no overflow. A leaf node is a node with no children. A leaf node is a node with no children, like this, like this, like this, like this. So let's draw it. 1, 2, 3. It's 1, 2 added by 1, 3. 1, 2, and 1, 3. Add up. So this is a simple DFS. 9, 0. It's a simple DFS. 9, 5, 1, 4, 9, 5, 4, 9, 1, 4, 0. This is a simple DFS. We just write helper to for a certain node, for some node, for node. We need 3 things. First, it's a value of its parent, and the value is of its current. The current is calculated by the parents plus 10 and added by v, the node's value, and its left and its children. V left, and V right. We use VR for short. If there are 2 situations, if a node is a leaf node, then we just return this value. If the node have left or right, then we just return the sum of these 2. So there are 2 situations. Okay, let's write it. Right, done. This is somewhat easy. We need a helper function. Before we write, let's think again thoroughly. For a certain node, there are the value of its parents, the value of the current node added by the parent, and we left, we right. If it is a leaf node, have no children, no left and no right, then we return it. If we have left or right, then we return the left value and the right value sum, such as the 4 or the 9 or something like a node. Even if it have only 1 children, like this one, no matter it's left or right, we still need to return the sum of its left and its right. We cannot use this value. Okay, so let's write it. This is a simple DFS with some states. With parent, with current, we use VL and VL for short. If have a depth node, then we use the current as the V parent to drill down to the left subtree. Then we just add it up at V left and right, V right. Because after this line, we are sure that the current node have some children. And when the hyper is called, the current node cannot be null. The problem, there are constraints that the number of nodes in the tree is in the range 1 to 1000, but we should check it before using it. When we loop the root, when we call the hyper first, the root is the current node, then the parent is 0. So this shall work. Okay, it works. So have a test. This is somewhat simpler, not so hard. Commit. Okay, it works. Time complexity, the CPU and the memory. Every node is accessed only once. So on we have no extra memory. But we access every node. The max memory cost should be the depth of the tree. Okay. Have a look at the solutions committed by other people. Yes, they are used helper, and we can save this value in the solution struct. in the class member. This is also the time complexity should be 01000 01. But the real memory, the largest memory should be log n. Because when we drill down, suppose this is a tree, when we drill down layer by layer to the depth, the memory cost is three nodes. Or we just access every one node. The stack is 3. I think this should be log n, but we just write a 1 here. Okay. And anything else to this problem? This is a somewhat simple problem. Okay, so this is today's daily problem. Some road to leaf number 129.